First of all, a very good morning, good afternoon, or good evening from wherever you belong to. It is a great pleasure to have you for this session. So, a warm welcome to one and all to this fireside chat with Vrushal Nanavati. This fireside chats are basically gateways to sharing our expertise and knowledge with all of you. In fact, just before we commence this session, I was speaking to Vrushal, and he said that there is a commonality when it comes to riding a bike across the mountains and finding the right 3D cloud technology. Before I tell you guys what he told me, I would like to know what do you guys think is the answer. So, can I request my lovely audience to put in the chat box? What do you feel is what are the commonalities that you can think of when you are riding a bike across the mountains or finding the right 3D technology solution for your business? So I see some, okay, I see twists and turns. That's right. Anything else that strikes your mind with that question? So let me tell you, while I would still request the audience to put in their answer in the chat, I'll tell you what Vrushal responded to me on this question. As he himself is an avid rider who has experienced a lot of mountaineering and biking, and at the same time, he has handled a lot of high level clients in terms of collaborating for 3D cloud technology. Before I could even guess a correlation, like an old wise soul, he said, while it's great to know where to go, it's very critical to know what not to do. That made me think about it that yes, that's really true. And that's why we are bringing this special fireside chat on common pitfalls to avoid while enhancing the 3D web experience in construction. For today's evening, it's my absolute pleasure to invite Vrushal Nanavati, whose expertise in 3D cloud technology is second to none. Vrushal started his journey with Encircle and quickly grew among the ranks to tech lead and advised and managed multiple successful collaborations on 3D cloud technology with clients across the globe. Vrushal, welcome to the Fireside Chat. Now, to commence this session, I would like to request Vrushal to throw some light on the evolution of 3D cloud experience in the construction industry. Vrushal, welcome once again, and the session is all yours. Please take over.
Thank you, Snigdha, for that welcome. Thank you, everyone, for joining today and making time. As we all know that the market has shifted its trajectory towards a system which can assure an effective collaboration, even remotely. This gave a way to rise of the web and cloud application in the overall market, including the construction industry. Before onset of cloud applications, cloud technology was able to contribute only 15% of productivity improvements and only 4 to 5% of the cost savings. In today's world, as per McKinsey's report on reinventing construction, cloud applications contribute almost 48 to 60% and productivity improvements and 27 to 38% of cost savings. The role of 3D or cloud has expanded beyond its traditional role. Now cloud-based applications enable collaboration and contracting, design and engineering, procurement and supply chain management, on-site execution, capacity building, and many more such use cases.
It does make sense, Vrushal, isn't it? With work from home becoming a new normal, organizations are now looking to make sure that even while working remotely, efficiency and productivity do not take a hit. Hence, 3D cloud apps have become very critical for the construction industry. So, after developing so many 3D cloud applications for over 20 different customers, did you find any patterns or similar mistakes that companies tend to make when developing a 3D technology? While Vrushal answers this for us, I'm throwing this question to our amazing audience here as well. what are some of the patterns or similar mistakes that you have been seeing or experienced organizations making while developing the 3D technology? I'm sure you might have come across your own set of challenges while choosing the right fit of 3D technology for your business. Feel free to write them in the chat box, and we will try to cover them in the course of this fireside and even beyond. Uh, we are also going to share a Calendly link in the chat. So I request people who have their questions, please try to put it in the chat and we will take them up in the Q&A session. But I would also request people who have some queries which are very specific to your business and you would want our team to get in touch with you for a one-to-one discussion, please feel free to book a slot for yourself using the Calendly link. So I'm going to put the Calendly link here in the chat box, which is going to come every now and then. We want you to please book a slot in case you do not get a chance to put your questions and we are not able to answer them basically during the course of this session. So Vrushal, coming back to you, what is your pick on this?
Yeah, absolutely. Like from my experience of building 3D applications, I have realized that, while every CTO and decision maker in organization doing their best when they choose a 3D technology, still many companies need to rework on the 3D components a few years down the line. The reason is some of these requirements are not very obvious at the beginning, or organizations underestimate the effort to support the new features. Let me dig a bit deeper here and talk about such a things which are realized often at the later stage of building such a platform or a an application which is helping the construction industry people. The biggest of these is performance issues. With more and more remote working, users are throwing even more bigger and more complex models at the system. And then users are the first one to crib about the performance. Increasing the performance of an existing system is not that easy task. Uh, Apart from the performance, we have one more parameter, which is wrong team for the job. Most of these viewers are JavaScript based, but JavaScript or TypeScript developers are not the best fit for 3D development. It can become make or break if the use of 3D technology without utilizing its full potential. Only people with 3D understanding can work and make the best use of such a technology. Updating and catching up with the support of the latest versions of the software could be another parameter which can be realized at the later stage after we select a technology as a base layer for our application or platform building, and then we build a lot of customizations on top of that. And now when the new versions and new upgrades of the base technologies are there in the market, we try and get into a maintenance and support. So every year new versions of CAD and BIM technologies, I would say, are released with several service packs throughout the year. So this is an important parameter to consider the upgrades of the base technologies that we use. A lot of development overhead is required for the new development. This is something which is related to if you have done too deep customizations inside a base layer or base technology that you have selected, and now while making more and more complex features developed on top of that and making changes into the base technology provider's code base, it makes the system even more complex and difficult to maintain in the now in the future for us. So adding one another feature into that existing complex development becomes a very difficult job.
Those are certainly quite strong points, I must say, Vrushal. And my dear audience, are there any other challenges that you have also observed or faced while building 3D technology in the long run? Now is the time to share it with us in the chat box. So please put in your responses and we will try to discuss them throughout this webinar. Vrushal, so if there are all these problems, what is the best practice to evaluate and adopt 3D technology in the right way?
Well, as Simon said, always start with the why. Define why we are building the 3D application and how users are going to use it. I personally categorize the purpose of such a platforms into following 4 buckets. These buckets are basic or advanced viewer, review and data applications, configurators, and editors. As we work on the purpose part of it, we also answer the following parameters that will help better decision making or to cast your application or product into these buckets. So what are these data points? The first piece is, of course, the data that is going to flow through the system. What all data needs to be viewed and with what level of accuracy. So when we address data, data includes geometry, metadata, model tree, materials, views, and many such parameters of a 3D or a BIM or a CAD model that we talk about. Then what kind of format, file format of input and output is required to the platform. Then comes the performance requirements, like the performance of loading the model, performance of interacting with the model, thin client, thick client, etc. Then we think about measurements. If we are going to do any measurements in the system, and if so, then with what accuracy? And what are all the types of measurements we want to carry on the given model? Another critical factor is that quality of visualization required. It depends on application to application basis, what quality of visualization is really required. For example, real estate application showing their portfolio, a good visualization is a plus. But a configurator or an editor might require the lesser visual quality there. Then we address the security concerns concerning the storage of the data and flow of the data throughout the pipeline from origin or the source of the data and how it flows through the system to the end users. And then business model. This is the important one. So how you are going to price it to your customers after you build a platform and prepare a business model on top. Is there any predictability in the approaches, or can you accurately predict the number of files or session time or the pattern of usage of the customers or the end users?
Thank you for sharing these points, Vrushal. That definitely makes sense. So we have spoken about data, input-output format, visualization, business model, and security as decision-making parameters. Here, I would like to ask my audience also, do you think there is something more to it than what Vrushal just spoke about? Hit it in the chat box and we will try to cover them during this session and beyond as well. So coming back to Vrushal, shall we look at each of these aspects in detail and how much it will affect the decision making? Because I'm sure all our audience along with me would be curious to know that as well.
I was hoping we would. So let's categorize the purpose now. So we would go and discuss characteristics of each of these buckets, which will help you decide or categorize your specific application into these 4 categories that we just talked about and what parameters affect these platforms. So first one is your application viewer or basic or advanced viewer, where only the visualization and interacting with the model is involved. For example, is it a model sharing platform like we have Sketchfab, GrabCAD, Flare 3D, Utopia, etc.? Or is it a product company wanting to showcase all its product? Example, BIM objects, parts, factory components, or any real estate company's portfolio, where the most of the data to the system is uploaded by the platform owner and many of the users only visualize it or use it for the visualization purpose, not uploading the data.
Right. Firstly, I would like to mention that I already see queries pouring in the chat section. So Scott, I see you already have a question for us. Rest assured, we will definitely take it up in the Q&A session. Because we don't want to lose on the time that we have for the webinar specifically. So we will definitely address it during our Q&A session. Coming back to the points that you mentioned, Vrushal, it's interesting to know, now that you have thrown some light on the used cases, let us talk about what do you think are the important characteristics to decide between basic and advanced viewer. I'm sure even our audience would be curious to know that.
Sure. So mostly for the viewer or viewing application, visual quality is a parameter. Other platforms more focused on presentation of the model and the repository of the models. Better visualization can help with better, the adoption. New versions of files are less common in these platforms, but once the files are put on the platform, many users will want to view the files multiple times. Ability to support a different file format is a characteristic, because we are wanting to showcase or have as many file format as required in the platform for visualization. Is mobile viewing important? Mobile support also adds a lot of value in today's world, not to mention. Some of the platforms are not focused on a lot of advanced workflows like annotations, measurements, etc. Since the products are presented in a specific way, the data associated with the components can easily be regulated by the technology provider or the platform provider. For smaller products like BIM object families, manufacturing components, very high performance is not required because the context is limited to smaller geometry and the data for visualization. If the data is put only by the data provider on the platform, number of files and even the file formats can be easily regulated, because most of the data on the system is going through the platform provider, not by the users or many people. So the format and the number of files to put is always under the platform provider's control. Whether we want to integrate GIS, 3D maps in our platform, it helps better visualization, of course. Again, for example, any real estate website to showcase the 3D portfolio of their projects executed. Not all BIM platform supports GIS out of the box and have limitations in its seamless integration. If you have applications where you want to showcase the actual geolocation site, example, just the real estate one, the GIS map integration could be helpful. And for some of the examples, what technology can be used is Cesium.js is a tool that provides a good support of GIS today. That could be a choice, but GIS is altogether a different topic, almost for another session. So yeah, we'll discuss probably GIS in brief today. So
yeah, definitely makes sense, Vrushal, and I'm sure GIS integration could be another session in itself together. So probably we have to plan for that as well, because I'm sure that must be interesting for many of our audience who are today with us, or even for some more who are not in the session with us. Coming back to our discussion for today, now that you have already given us this input about you have thrown some lights on the basic and advanced viewer. Now, my next question to you would be if you can also take us through some use cases for review and data operations, because I'm sure that also plays a very critical role.
Definitely. So our next bucket is review and data operations, or the platforms where the data is reviewed and managed by multiple people. Collaboration is required. For example, review, feedback, and collaboration platform that needs to support construction coordination. Facility management platform, where ability to visualize the facility management data in the context of 3D model is crucial. Project management platform, digital field platforms. So these platforms comes under the review and data category of the applications.
These are definitely some quite relevant examples, I must say. Also, I see a lot of comments and questions pouring in. So we have a huge point from Jim, I think. Jim, we would definitely like to discuss this. It would be really helpful for us if you can give us time and block the Calendly link for a quick meeting, because I'm sure I see a long message from you. So we will definitely discuss this ahead. I also see a query from Scott again. Can you talk about visualization of point cloud and BIM models together? That's a very interesting question, Scott. We will definitely take this up in the Q&A session. Coming back to our discussion again. So as the next step, Vrushal, what are the important characteristics to consider for review and data operations?
Sure. So some of the categories for review and data or characteristics for review and data are, the users who wants to do measurements of various kinds. There is an overlay of data from, sensor or facility management data. We need to create RFI and link to specific entities. There should be comments and comment history associated with the components. High accuracy of the data is required because here the reviewing is done, the quality checks are being done on the platform. Since such platforms are focused on specific workflows, a very high quality 3D visualization may not be crucial, but if you are working with C-level executives, real-time rendering with high quality can provide a lot of benefits. Example, Unity Reflect could be used for very good visualization. Business model wise, the most preferred business model for user is per user pricing with no limit on number of files. And this could be one of the very important factors in 3D technology selection in such cases. Most of the or few of the technologies in market charges per file, but that could not be a right business model for the end users of our platform, even if we are selecting or choosing a best technology which is charging per file. Security of data is also critical in such a cases because it will allow large organizations to control their data in-house on their private cloud, or it will be hosted on third-party servers.
Makes sense. So here I would like to ask my lovely audience, do you think your application falls under the review and data operations bucket based on the characteristics that we just discussed? Hit it in the chat box. That will help us understand your requirements and the kind of challenges you face as well. Once again, we are sharing the Calendly link now in the chat. So people, please feel free to go ahead and book appointments so we can talk to you. We as in our team, Vrushal and Vrushal's team will get in touch with you, have a quick discussion, and we will try to have customized solutions for your requirements. So please feel free to go ahead and book your slots. Now, by the time I leave it up to the audience to hit their applications and their responses in the chat box, Vrushal, for the next bucket of configurators, what can be considered as good use cases, and then dig deeper with the important characteristics for our audience here as well? I'm sure they would like to know that.
Sure. So the next category, as Nigna mentioned, it is configurators. So name itself, denotes what kind of applications could be falling under this category. So configurators, this category have application or platforms where there are pre-configured presets or limited choice of configurations already provided by the platform provider. User have a playground where they can configure out of preset configurations. For example, here we can see one interior designer or a plan designer where you can just drag and drop a type of chair, a type of window, a type of wall to create your, let's for example, an apartment structure. So here out of the predefined configurations, user can play around and customize their design or final design. So such applications are configuration applications. So as I said, few examples of that is tile configurations, floor plan layout configurators, BIM or object configurators, home design and interior layout configurators, etc. These platforms need to provide users with a lot of templates and then allow users to customize various parameters of the design. It needs to update the geometry and visualization quickly as user is, configuring, just selecting on the UI, and you need to update the geometry quickly to showcase that configuration to the user in real time. Customization parameters could be only visual parameters or geometry parameters as well. When considering geometry editing, we need to evaluate if editing geometry in 2D is more efficient or directly in 3D. For example, if you're building a home configurator, editing the layouts in 2D is convenient. And finally, building a 3D visualization after a 2D plan is well configured, that keeps our platform smooth for the end users and there are no performance lags. Visual quality is important if the product is end user centric. For example, if you are focused on home layout or furniture, good quality visualization will definitely increase the chance of purchase. For some other components, the visual quality could be secondary. Finally, after the design is complete, we need to evaluate how the design will flow downstream, and hence the output format is critical. Example, we have built this web platform for building, let's suppose, the configuring an apartment. But after the apartment is configured, if that apartment is going to be utilized with conventional desktop softwares or any other tools, we need to support from proper export format so that it can be consumed for the downstream applications or consumptions.
That definitely looks fascinating, as this category equips user to quickly configure designs and products. So I would like to put this question for my audience here as well. Does your application also require quick configuration for the customers to build their end designs or products on your platform? Please mention your answers in the chat, and we would really love to know how you're dealing with this. Now, moving on to the editors, Vrushal, could you take us through some good use cases for that as well and characteristics for the same?
Sure. So with the characteristics of the examples for editor use case, which is our next bucket, few examples to list: plan process designers, material property editors, for example, for the Revit files, direct floor plan editing in the cloud, like for example, Aries Kudo, or building any, customizations or design tools on the web. Everyone must have heard of OnShapes, right? There, ideally, you can do anything, which is we can do today in the desktop applications for the design part. The typical characteristics for this category application is that since everyone is working remotely, these platforms provide capability to create designs and edit the files online. A lot of you must have heard of course, the example of OnShape that I just talked about. You can practically do everything what you can do on the desktop CAD. Aries Kudo, AutoCAD Web offer you the capabilities to edit the DWG files online. Such engines do not have a very good geometry kernel, or they do have a good geometry kernel running in the background. People need to be able to work with many controls and components to do things on the cloud, similar to what they do on the desktop application. So we basically separate the computing part of these softwares and put those in good performing servers where the computing happens, and we prepare a user interface on the browsers so that these because modern browsers are good, computationally good, but not as good as the desktop yet. So building design and editing applications, if they have computationally heavy tasks, we would want to shift those on the server part of this pipeline. Typically, some of them do need support or do need to support input and output specific formats so that when people complete their designs on the cloud, other collaborators can still work with your design in traditional desktop application. This is the similar case we just discussed with the configurators. Whatever configuration you have built, if that needs to be consumed further in the pipeline, that needs to be exported in specific file format. Some of these platforms can add a lot of value with co-editing, which is like Google Docs, for example. Multiple people can work on the same design simultaneously. Visualization quality is not of that highest importance because more focus is on editing and formation of the data, not the presenting of the data in such a platforms where our applications falls under the editing category.
Thank you, Vrushal, for explaining the characteristics using some wonderful use cases. Now, I would like to again come back to the audience and still try to get some responses from you in the chat box. Do you think your application doesn't fall under any of these buckets? If so, let us know in the chat. And we would definitely like to connect with you and be on this session and have a discussion. All right, Vrushal, now that we know different kinds of use cases, let's discuss how the parameters like data, security, and others may affect the decision making.
Sure. Let's talk about data first. What all data needs to be viewed and with what accuracy is, an important stuff to discuss before we even, kind of choose a right 3 technology. So after we categorize the purpose, this is again, while categorizing the purpose, one of the important parameter is the data and what users are going to do with the data. So data includes again geometry, metadata, model trees, materials, properties, and many more data, which is really could be related to IoT today, like digital twins. The data is flowing with the sensors and whatnot. Now, to understand which 3D technology is best at providing accurate data, you need to understand what is the conversion technology used behind. Let's understand the pipeline first. So, there are almost, I guess, 60 plus file formats available for CAD and BIM applications for the desktop softwares that we have today. If we combine all of them, or even more, I might be missing many of them. Now, these file formats have their own way of storing the data in it. Some of them are proprietary, some of them are open standards. But now, not all these files we can directly view in the browser-based viewers. So we need to convert all these file formats using a conversion tool to convert them in a common viewable file format, and then we can visualize these models in 3D viewer. Now, the fact that if you see the pipeline here, there is a native file, then there is a converter, then we have converted that file into a browser viewable format, and then we are able to load this into the 3D viewer. Now, going forward, we have different files. So we have different converters to convert them. So based on our application, whether it is BIM, CAD, or any other application, where the application could be in, creative industry, animation industry, these models or the converters used could be at different level of stage, or we need to check really or do the due diligence on what all data these converters are able to extract from the native files and are being able to transfer to the browser viewable format so that the same data can be visualized in the browser as well. So, summarizing this, that, the conversion of the file format to the browser viewable file format does not guarantee 100% data conversion. although most of them, does a good job at it. Each file format converter is again different. They might be at different stage of maturity of converting the file format. So most of, again, there are multiple parameters when I say about the level of maturity of these file formats. So for bringing an accuracy, even if we say that we want a geometry to be converted, there are two things to consider: whether it is a tessellated 3D mesh data that we are getting from the native file, or we are able to somehow extract, a more accurate information from boundary representation, which is mathematical model, which is used to define or to store the geometry information. These parameters define further going the level of accuracy in the measurements that we are going to get, because tessellated data is merely a resolution based representation of geometry having the set of triangles. Now if you do or carry out the measurements on top of such a data, those are not very accurate for engineering purpose of the review and collaboration. So if there is a requirement of BREP and more accurate data to be available for measurements in these viewers, we need to explicitly go and check with the capability of the converter converting these files. So talking about the data, geometry is one information or one type of data here. There could be, metadata or properties which are recently being used for, quickly searching the elements out of a huge models, querying interfaces people are building in order to fetch very quick data from a very big model. It's just, on tip of your search bar, whatever you want to search. So this metadata, if is available in a proper format, then our system could be much more user friendly for the people, saving more time in their design and review applications as well. Then there is a model tree. Then other information which is usually used in the BIM and CAD is views, colors, textures, properties of each elements, then unique IDs or GUIDs used per element. So these are the data probably are most important while we are building the application. Out of these, we can think about which data is important for our platform or the platform that we are building. Most of the toolkit providers do not provide any control over the converter that they are using. So after you choose the 3D technology, if you find a flaw that some converter is not converting specific things, then we don't have a direct control of going and fixing that in the converter tool. Usually this control is towards the converter provider or technology providers, and we will have to wait for their updates or request them for that fix or report them. So it is very important to have a due diligence before we choose the right toolkit for our platform. So what is the best way then? So I usually suggest that create multiple examples, ensure that the most of your data is getting supported before adopting or planning for adopting a 3D technology toolkit, or buy some additional time to go to market.
Well, that does make sense to me, and I'm sure to our audience as well. After all, data is the king, like we say. So, in that case, Vrushal, my next question would be, what about the input output? How does that impact the decision making process?
So I think, again, the input output is also important because data is the king today, right? So as we discussed, every 3D technology has different level of support for different file formats. There are a few other considerations with respect to file formats. For example, if you want to support the IFC file format, some application or customers may demand that the platform should be IFC certified. So you need to make some more efforts to make the standardization or get it verified as per the standards that our platform is exporting the IFC in a certified or standard way. There might be additional efforts required for the certification. Another aspect is that not all formats are supported in single 3D viewer. For example, you may need to consider a combination of viewer technologies if you're dealing with 3D PDF or 3D files or point clouds and GIS data. So recently, we are facing applications combining not just the BIM models, but they want, point clouds along with that loaded plus GIS data as well. So where we actually see the construction BIM model with a proper realistic context on actual geolocation on the earth, along with, the review with the recently, point cloud scanning is becoming a new cool. So in such a cases, you need to choose a right toolkit while dealing with all these technologies and file format simultaneously on the same platform. So the architecture of such a system is very, very crucial for long-term stability and scalability. BIM technology companies are not many, and among that, the specializing those which are specializing in interoperability are very handful companies. So it happens many a times that the companies use the same technology on the back end to read specific file formats. If you understand which technology is used in the back end, then you can easily judge the accuracy of the file format that they must be supporting. You should also check how quickly a new version of the file format will be supported by the conversion technology provider. This is important because once you adopt the technology, all the file formats that are supported by the authorizing or conversion tool, they need to support all these file formats, newer versions regularly. So how fast the service provider is able to provide these new versions is an important parameter to consider. Just to give you an example, Autodesk technologies might support new versions of Revit files faster as compared to few others because Revit is again an Autodesk product. So you may need to choose the technology according to your conditions, and these are the parameters from data and input output perspective, which may help the decision making for you.
I must say that was explained with some really relevant examples, Vrushal. Coming back to my audience, do you folks also have faced any issues with data and input output? If yes, then type your issues in the chat box and we will be more than happy to help you and discuss them. Before we jump into performance requirements as our next parameter, let me ask our audience if you have ever faced long model loading time in your 3D viewer or lagging browsers while interacting with the models. As I understand, this is certainly a performance challenge that needs addressing. And how do they factor into our decision making? Vrushal, would you like to throw some light on this as well?
Sure, makes sense. Performance is very difficult to estimate at the start because even today we are getting surprises with new customers throwing a very huge model at the system, and we are struggling continuously with the user the user performance requirements and the user overall experience by loading that model and interacting with it. So here is my suggestion. Usually, the companies or product-based companies develop a 3D viewer on top of plain WebGL or open source components, but then spend a lot of time improving the performance and other aspects of these inbuilt or in-house built tools. But this happens mainly with in-house developed viewers as I'm talking. In the long run, if you compare the cost of development of such a platform in-house versus licensing a technology which is already supporting it, and the opportunity cost of getting early to the market, you will realize that you are better off licensing a technology rather than building one. The successful implementations of in-house 3D viewers are those which are not dealing with large files, and are more focused on configurators probably, because where you are configuring, you can control the configuration of pre or pre-estimate the configuration required for these platforms. Various kinds of performance optimizations needs to be built to make a high performance 3D viewers, because we are seeing in several of GBs of data getting thrown at our systems to load that data faster in the browsers, and being having limited configurations and the computing power on the devices. The performance lag is a common problem. Now, the optimizations like progressive loading, lazy loading, where we demand the data only when it is required, continuously updating the viewer. These things matter, and these things need a lot of research and implementation of complex algorithms, and geometry buffering is another thing. Now, when you pay a good license fee to the third-party viewers, you are basically paying for these features. So that again a good decision-making parameter here, whether your application you should be building on your own from scratch or better off licensing a technology.
Makes sense. So, what is the solution for applications that need to work with very big models, but on very thin clients?
Yeah, so the answer is server-side rendering. In simple terms, it's like remote connection to the high performance server, which is loading a large model and streaming video to thin client. With server-side rendering, you can load huge models on any device which can stream a video, including your smartphones, even with the 3 GB, 4 GB of RAM with good performance. However, such infrastructure has a high running cost because all the computing power on every client which is loading that particular model is controlled by the server, or it is executed by the server. So in such applications, you need a constant internet connection and a high performance server hosted by service provider to smoothly render that model to the client.
Interesting. But what about the security concerns for storage of data and flow of data?
So for any cloud application, basic security checks are necessary. And you should prepare your system for Open Web Application Security Project top 10 security risks. However, let's look at how some of these will be critical for your choice of 3D technology. If you remember the pipeline that I showed a few minutes back, we have native file format, we have a converter, and we have a browser viewable format, and then we view. This is a pipeline where the source of the native files could be this platform provider or the end users, depending on your bucket of the application. And then converter is where the data is actually fetched, converted, and outputted into browser viewable file format. And browser viewable file format again needs to be saved somewhere so that we can load that into the 3D viewer. It is important to understand where each of these components are located and how the data is flowing through this pipeline and where it is getting saved. Some viewing and conversion technology companies provide you with the converters and viewers to be hosted on your platform, on your private clouds, while some other viewing technology providers have converter hosted on their servers, and the file goes to the third party server, and for some time it resides there as well. You may need to implement specific steps to delete the content after conversion from the third party server is done, because the file is uploaded on the third party server. So we need to delete them after the conversion is done.
Considering the sanctity of data, it absolutely makes sense to me. But another concern that I may think of, and I'm sure many of our audience members will have, is that even if we host everything on your private cloud, some must be concerned about what data is sent to the client devices. Is it possible for someone to reverse engineer the model using that data?
In most cases, at least the tessellated data is sent to the client devices, and some expert might get access to the tessellated data for the lifetime and may use this for reverse engineering. If you want to control even that, like the model data or the geometry or the mesh should not also be sent to the front end to any users, you may want to consider the server side rendering option that we just talked about for thin client supports like mobile applications. So in this case, we just render or send a video of the model to the front end, just a video, not the model data. So any information is not revealed apart from the video to the thin clients or the server, the customer or client side access.
So, my dear audience, this question is for you. Do you delete the content after conversion from third-party servers? Or do you want to control what information flows to the client side? If you're having similar concerns about the flow of data, type yes in the chat box and we can connect one-on-one to solve such issues. Moving on to the next parameter. So, Vrushal, how have you seen measurements impacting the decision-making process?
If you're going to do any measurements, we need to consider the accuracy of measurements and type of measurements required. If measurements on 3D model is very critical for your application, it is important to check if the viewer loads measurable entities like edges, segments, points, vertices, apart from just the triangles or tessellated geometry to represent the shape. Measurements on tessellated geometry are not very accurate, as we talked before, because tessellated geometry is resolution-based representation of the shapes or the geometry. So we might want to extract data from actual BREP entities to support more accurate measurements.
And what about the visualization quality? And also, how does the mobile viewing come into making the right decisions? Can you throw some light on these aspects as well?
Yeah, so if visualization quality is of prime importance, apart from the out-of-the-box support of various visualization settings provided by the technology providers, it is important to check if we have access through APIs to lower level rendering pipeline up to a level where we can write our own shader programs, where we can control the behavior of or the quality of rendering, or we can write our own rendering pipeline with our own calculations of light, and improvise the visualization. So shader can enable the implementation of advanced visualization techniques, in short, and improve the visual experience of your customers, and allows, of course, the better customization to your specific platform. When it comes to mobile, there are two ways to implement the mobile compatibility. In some cases, the viewer is developed for the browser, and the same is used in mobile as the browser based embedded in the native application. So it's like embedding little browser inside the mobile application itself, and let it run the same program which is natively written for the web. That's one thing. And in some other cases, there is different viewer for mobile and different one for browser provided by the technology provider itself. The advantages of native viewer is that it has somewhat more capabilities as compared to browser-based application, especially if you're trying to implement AR, for example, along with the 3D view. Because that is written in a native language support, and it's not written just the web in the web technology. Because it is written in mobile technology, it allows more control and features which are specific to the mobile application. But the trade-off here is that mobile and browser based viewers are generally having gap in the capabilities or user experience, I would say. So basically, because those are written in different technologies, and those are two different developments, there is always a gap in the user experience that you're having on the web and you're having on the mobile, because these are two different products developed. And another thing is that you need, to separate development teams to customize and support them. And again, you have two different pipelines for maintenance. So yeah, it's probably a trade-off whether you want to use same browser-based tool as an embedded viewer inside a mobile, or you want to adopt a technology which provides altogether different technology toolkits, and you are making more use of native tools which are provided by Android 9.
So Vrushal, now that we have covered quite some technical aspects that needs to be considered while opting for the right 3D technology, what are your thoughts how these platforms can be priced to the end users and how the business model would affect the decision making? But before I come back to you for your thought process, I would like to mention this to the audience that since we are running out of time, we will definitely try to take as many questions as possible for the Q&A session, but I would still request everyone to put in your comments and your questions in the chat box. We will address them individually and our team will be happy to come back to you, even if we are not able to address them in this session itself. So please make sure that you put in your comments and your questions in the chat box. And once again, I'm going to share the Calendly link. So please make sure if you have any queries which you want our team to discuss with you, understand your requirement one-to-one, please go ahead and book the Calendly link. So coming back to you, Vrushal, I would definitely like to know your thought process about how the business model would affect the decision making here.
So the business model is the secret sauce for decision making now, because the factors like how you're going to price it to the customers. Now we discussed a lot of technical things, but now we are thinking of making business out of the platform that we've built probably. So here, a few questions we can ask ourselves that, are we able to predict the pattern of the usage of our platform by the end user? So it could be per file, it could be, per user with unlimited file access, or, it could be session time dependent as well. How you better predict the usage, it will help the decision making for you, easier to choose the right business model here. So as far as, just to categorize very briefly, we have three that I mentioned, three types of business model where we can charge the end users per file based pricing, then license fees with or without royalty components with unlimited usage. No matter how much files there. Pricing is based on the session time, on views, and the amount of time user uses the platform. You will need to evaluate which type of business model suits your needs. For example, in facility management software, the change in 3D model are less common and only the metadata is changing. So per file pricing of the 3D viewer is okay for end users and convincing. And you can still charge a fixed subscription fees to your customers, apart from the per file upload that they are going to do to the platform. However, if you have a project management software where users might upload unlimited number of files, user might incur a lot of cost of course, as a technology provider, you might incur a lot of cost on converting every 3D file, because you might have chose a underlying 3D toolkit which is charging per file conversion. But such a per file pricing to the end user is not a best fit, because for them the platform should be for project management, and they should be able to use or upload as many files as they want on their system. So if you go with the server side rendering kind of an application, you may have to price the customers based on the session time or number of servers required, because of course here the heavy investment is on the heavy servers which are doing the computation for the users. So a session-based pricing could be a good deal. The number or the amount of time user is spending utilizing our platform equivalent to the price.
Thank you, Vrushal, for informing me and our audience about all the important parameters that are crucial while choosing the right 3D technology. I know some of you will have specific questions that need answering. So here we have already shared the calendar that you can block. Since we are running out of time, we may not be able to take too many questions in our Q&A session, which is going to come up. So I would still request everyone to put in your comments and your questions so we can check them and come back to you individually for that. This brings us towards the end of our webinar. However, before I let you go, Vrushal, I'm going to put you in the spot right now and ask you to list some technologies that our lovely audience may consider for their business. So just imagine me randomly walking up to you and asking, Vrushal, what could be some of the technologies that I may consider for the 3D for 3D experience, 3D technology implementation? What would be your response to that?
Okay, so based on again, the use case, I can list a few technologies here. For example, considering really, CAD and BIM use cases, we can have, Autodesk Forge is a good toolkit, or a viewer can be used to build your software on. Hoops Communicator is another, I would say toolkit which is good for building your platforms. ODA Visualize is also a good tool, and these tools are, I would say, giving a combo with converter plus viewer. They are not just the viewers. Ariskudo is another, example of the use case. Now, in case of, if when you want really good control or presenting of the data is important with AR, VR, and with good quality visualizations, Unity, Unreal could be the solutions to build your platforms into. There are some open source toolkits or 3D libraries available like 3.js, Portree. These could be used for general purpose because they have a lot of customizations implemented, plugins and extensions, and you can use them for any 3D related application, no matter only for CAD or BIM, but for even I would say creative industry as well. And then if you are dealing with GIS data, and if your applications are falling under GIS category, then Cesium.js, ArcGIS, VTS browsers, these are the good libraries that you may consider.
Thank you so much, Vrushal. I'm sure I did definitely find this session a lot insightful, and I'm sure our lovely audience would also agree with me. So thank you. Thank you for this wonderful session. It was really insightful and very informative.
Thank you, Snigdha, for having me to this session today. Thanks everyone for your time as well.
I'm sure, like our audience, I'm now well aware of not just the common pitfalls, but also what are the crucial parameters to consider for making the right choices of technology, as well as the app strategy to make the best choice and develop the best tools. So, my dear audience, we would be more than happy to get on to one-on-one call to discuss the pros and cons of various technologies for your business. We are sharing the calendar again, so book your consultation slot and help us to help you. Now, I would like to open the session for further Q&As, but since we are running out of time, I'll just quickly take a few questions that I could see which are already there in the chat. So, Vrushal, the first question that comes your way is, as you mentioned that you have worked for nearly 20 customers on cloud apps, what was the most common problem observed? Vrushal, would you like to take this up?
Yeah, sure. So I think there are many problems we face during the course of being developing the 3D technologies. but most of them related to visualization and performance issues, because over the time people are throwing very big models at the system. For various application, performance is a bottleneck still. And then apart from the performance, then interoperability or supporting various file formats to a specific platform is another challenging challenges that faced by many of our customers. Yeah, so these are, I think, probably a few things I would name which are most commonly observed as a bottlenecks or problems.
Okay. The next question that we have in the chat box is, can you talk about visualization of point cloud and BIM models together? That sounds definitely an interesting one to me. All yours, Vrushal. What would be your pick on this?
So yeah, I mean, recent applications are going, or requirements are again coming, like for point clouds and BIM to visualize, the scan data plus, the built model together, scan to being becoming again, a good new cool or trending technology. It is possible, still to include, and recent weavers also have supported now a point cloud, but together also people are improvising on the toolkits. Portray is good at loading the point clouds, plus a good 3D viewer could be a good choice at this point to combine these two applications together in at one place or in one platform, I would say.
Okay. I see another question, and this has come from Scott. What is a typical timeline to adopt 3D technology in existing platforms?
I think another good question, but it depends really, I would say, because we had customers to build quick configurators, or few customers who really wants to build a viewer technology to load their existing models. So and we have customers who wants to support all the dimensions of the build, from scheduling, energy management, digital twins, facility management, IoT data integrations, then scheduling. So all these in a one platform. So it really depends on what application we are building. We have dealt with some customers to enable the viewing of the models in 1 week as well, and few of the customers we are working with more than 4 years now to support more and more features to the platform.
Thank you for the response, Vrushal. I see few more questions in the chat box, but unfortunately, since we are already overshooting, we will have to call this session, and I promise we will definitely get back to you. If you have the questions in the chat box, our team will certainly come back to you for your responses of your corresponding questions. So I would finally like to conclude this session. And like I said, thank you, Vrushal, for giving us such an informative and insightful session. And I would definitely like to thank my lovely audience to spare time and be with us for this session. Thank you once again for your time, and have a great day ahead. We look forward to have you in the upcoming sessions as well. Thank you again. Have a great day ahead.
Thank you, everyone.